The audio signals that we've been working with can span a range from -1 to +1. Therefore, the maximum magnitude any signal can have is 1. We will use this level and define it as full scale. We can use it as a relative level on our decibel scale and call it 0 dB full scale. When we perform peak normalization, the idea is to change the amplitude of our entire signal such that the signal's peak amplitude reaches some normalized level or desired amplitude relative to 0 dB full scale. Let's take a look at writing some code to perform peak normalization. Here's a demonstration of some steps to change a signal's amplitude by using peak normalization. I'm going to start out with a simple input signal to help us visualize the process. In my script, I've created an array that we'll use as our signal, then assigned it to a variable called n. Down below, I'm going to plot this input signal by using a stem plot so we can look at it. Here I'll run the script. We can look at the result. Here's our signal. It starts with an amplitude value of 0, increases to 0.5, decreases down to -0.5, and then returns to 0. What we like to do with peak normalization is scale the amplitude of this signal such that the peak value takes on some specified criterion. As a first example, let's say we like to change the amplitude such that this peak has a value of 1 instead of 0.5. We can borrow a rule from mathematics that says any number divided by itself is going to be equal to 1. So 0.5 divided by 0.5 equals 1. If we had a signal that had a peak of any number, 88, we could divide by that peak. 88 divided by 88 will also equal 1. Then we can realize that division is equal to multiplication of 1 divided by a number. So what we can do is multiply by 1 divided by 0.5 as our amplitude scaling factor. Keep in mind we're going to apply that same scaling factor to each sample in our signal. That gives us the steps that we need to do to normalize the amplitude of this signal. So let's start incorporating some of these ideas into our code. First step will be to measure the peak amplitude of the input signal. In a previous video, I showed you how you could do this process in 2 steps. Here, I'm going to consolidate it into one command. We'll call this the signal peak is equal to the maximum of the absolute value of our input signal. What I'll do here initially is print this result down here to the command window. We should see that we measured the signal peak to be 0.5. That's exactly the result that we see. So our next step is to normalize the amplitude by using the signal peak. So here our output signal will be equal to 1 divided by our signal peak, or 0.5. We're going to multiply that same number or scaling factor times each sample in our signal. Now we'll plot our output signal instead. Here's the result. We now produced a signal that has a peak value of 1 and -1 instead of 0.5. To show you that these steps will work for any other kind of signal, instead of using this simple one, I'm going to use an audio signal. Here I'm going to import a recording of an acoustic guitar that I've got stored on my hard drive. Initially what I'll do is plot the input signal, and we can look at what its maximum value is. So I'll run the script. We can look at the waveform. Here, this signal has a maximum value close to 0.6. In fact, if I come down here to the command window and look at what our signal peak is, we see that its maximum peak value is 0.6447. So we're going to be incorporating that here in this step. So now I'll run the script again, except plot the output signal. We should see that the amplitude gets scaled such that it has a peak level of 1. And that's exactly what we ended up with. The peak value here is actually -1. So that's great. We stay within the bounds of -1 to +1. The last step that I'll show you to incorporate in our code is going to be, what if we wanted to change and normalize the level to something else other than 0 dB full scale, or an amplitude of 1. This is a common parameter that shows up in digital audio workstations when you're going to perform peak normalization. So here what we're going to incorporate then into our code is a way of converting a decibel level over to a linear amplitude level that we include in this last step too. So now that we've essentially scaled our signal up to have a value of 1, now we could apply some other additional scaling factor to reduce the amplitude to 6 decibels less. Okay, so let's add a step in here to a desired decibel level. So the audio engineer, the user, could say they'd like to normalize to a value of -6 decibels. Here, our amplitude is going to be on the linear scale. Call this amplitude on the linear scale. This is where we're going to use the conversion from decibel to linear. 10 raised to the power of our decibel level divided by 20. Then we can incorporate and use this linear scaling value down here. So after we normalize it to a value of 1, then we scale it based on this requested decibel amount. So now let's plot this. We should see that the amplitude reaches -0.5 to +0.5. And that's exactly what we get. The user could put in -12. Now we've gone down to -0.25, or 1/4 of the amplitude. So these are the steps that we can use to perform amplitude normalization relative to the decibel scale.